Hello everyone and welcome back to our channel. Today, we're journeying back in time, over 1,000 years ago, to the bustling city of Cairo during the Islamic Golden Age. We're going to uncover the story of a man whose genius still echoes in the technology we use every single day. His name is Ibn Yunus al-Misri, and he is one of history's greatest unsung heroes of science. Have you ever used GPS to find your way? Or checked a weather forecast powered by satellite data? If so, you've indirectly benefited from the work of this incredible astronomer and mathematician. So, who was this remarkable figure, and how did he lay the groundwork for our modern world? Let's find out. Abu al-Hasan Ali ibn Abi Rahman ibn Yunus al-Misri was born around 950 CE in Egypt. Imagine growing up in a home where knowledge was the greatest treasure. His father was a famous historian and scientist, and this environment sparked a fire in young Ibn Yunus. From a very early age, he was fascinated by the stars, the planets, and the elegant language of mathematics that described their movements. This wasn't just a casual hobby for him. He lived during the powerful Fatimid Caliphate, a time of immense intellectual and cultural flourishing. The rulers were patrons of the sciences, and they built grand observatories, creating the perfect setting for a brilliant mind like his to thrive. Ibn Yunus dedicated his life to one of the most fundamental principles of science: systematic, precise observation. He would spend countless nights meticulously tracking the movements of celestial bodies, recording everything with unparalleled accuracy. This approach, collecting data, analyzing it, and drawing conclusions, is the very bedrock of modern experimental science. He wasn't just looking at the stars. He was having a conversation with the cosmos, and he was writing down everything it told him. His dedication culminated in his masterpiece, a monumental work known as al-Zij al-Hakimi al-Kabir, or the Great Hakemite Tables. This book wasn't just a collection of notes. It was an astronomical encyclopedia. Named in honor of the Caliph al-Hakim by Allah, it contained thousands of detailed observations and calculations. He documented the positions of the sun, the moon, the planets, and the stars with a level of precision that was unheard of at the time. Think about it, this was long before telescopes, computers, or any of the tools we take for granted today. He did this with simple instruments like astrolabes, but with a brilliant mathematical mind. The accuracy of his Hakemite tables was so legendary that they became the gold standard for astronomers for centuries to come. Fast forward over 500 years to the European Renaissance. Giants of astronomy like Nicolaus Copernicus, who proposed the sun-centered model of the universe, and Tycho Brahe, renowned for his own incredibly precise observations, were studying and referencing Ibn Yunus's data. His work transcended time and geography, forming a critical bridge of knowledge that helped fuel one of the greatest scientific revolutions in human history. His calculations were so reliable that they were used to verify and develop new theories about the cosmos. It's a powerful reminder that science is a global, multi-generational effort, with each great mind standing on the shoulders of the giants who came before. But Ibn Yunus's genius wasn't limited to just observing the sky. To make sense of what he saw, he needed a powerful mathematical toolkit. And when the existing tools weren't good enough, he invented his own. This is where his contributions to trigonometry become truly revolutionary. He was a pioneer in spherical trigonometry, the branch of math that deals with shapes, angles, and distances on a sphere, like our planet Earth. He developed new formulas and methods that made complex calculations much simpler and more accurate. These weren't just abstract equations. They had incredibly practical applications. For instance, he created a formula that was a precursor to the famous law of sines, which is a cornerstone of trigonometry taught in schools today. So why does this ancient math matter to you now? Let's connect the dots. The principles of spherical trigonometry that Ibn Yunus refined are absolutely essential for modern navigation. Every time your phone's GPS calculates your position, it's using complex algorithms based on the geometry of a sphere. The satellites orbiting Earth communicate with your device. And to pinpoint your location, they solve a geometric puzzle on a global scale. The mathematical foundations for solving that puzzle were laid by Ibn Yunus over 1,000 years ago. From navigating ships across vast oceans in the past to guiding aircraft and spacecraft today, his work is silently powering our ability to know exactly where we are. His influence doesn't stop there. Think about the massive observatories we have today, with giant telescopes peering into the deepest corners of the universe. The spirit of these modern marvels can be traced back to Ibn Yunus's methodical approach. His insistence on precise, repeatable observations and meticulous data recording set a new standard. He demonstrated that astronomy was not just about philosophy, but about rigorous measurement. This scientific discipline inspired generations of astronomers to build better instruments and develop more sophisticated techniques, leading directly to the powerful telescopes that allow us to discover exoplanets and distant galaxies today. And what about time itself? Our modern world runs on a precise synchronized clock. Ibn Yunus's accurate calculations of the sun and moon's positions were crucial for improving calendars and timekeeping. This was essential for everything from religious observances to agricultural planning. Today, that same precision is vital for technologies we depend on. Satellite programming, for example, requires incredibly accurate timing. Climate prediction models rely on historical data and precise orbital mechanics. Even our global financial systems depend on synchronized time. The quest for precision that Ibn Yunus championed continues to be a driving force in technology. Ibn Yunus passed away around the year 1009, but his legacy is immortal. He was more than just an astronomer. He was a true pioneer of the scientific method. He showed the world the power of combining observation with mathematics, a principle that now defines virtually every field of science and engineering. His discoveries weren't just isolated facts. They were foundational ideas that helped shape the course of human knowledge for a millennium. He is a shining example from the Islamic Golden Age, a period where scholars from diverse backgrounds preserved ancient wisdom and forged new paths of inquiry, ultimately paving the way for the modern world. So the next time you use a map on your phone, remember the story of Ibn Yunus al-Misri, the brilliant mind from medieval Cairo whose passion for the stars helped us navigate our own world. He reminds us that curiosity is timeless and that the quest for knowledge is one of humanity's greatest adventures. Thank you so much for joining me on this journey into the past. If you enjoyed this video and want to learn more about the hidden figures who shaped our world, please hit that like button, subscribe Freedom Mind channel, and ring the bell so you don't miss our next exploration. We'd love to hear your thoughts in the comments below. Until next time, stay curious.